Welcome, everyone. I see Con. Hi, Con. Nice to see you again. And I will start this a little slowly so we can get it going without worrying about time and head count. I want to mention that the name of this hour is AI at Exoscale on Global Networks. I am delighted to be with my good and longtime friend, Larry Smarr, Distinguished Professor Emeritus at University of California, San Diego, and the founding director of the Cal IT2 Institute down there, among many other things he's done and been. And I will mention that at the end of this conversation, we will have 10 minutes for audience Q&A. So if you have questions for Larry during our conversation, please drop them into the chat, and then we will call on you directly at that time. So Larry has asked me to mention something which I will mention now. We're having a very interesting thread now through FIRE after only a day and a half. And that began with Barrett's and my conversation at 9 o'clock yesterday, where we suggested that there was not only a very large schism occurring geopolitically and economically and technically in the globe, but in time. And that there was this next age, suddenly a discontinuous change, as Larry described it, between yesterday and tomorrow. And that we needed to kind of digest that as a society and understand what it means and go forward from there. And then, of course, for those of you who are technical, you were no doubt on my conversation with Carver Mead, the chip pioneer, yesterday afternoon, in which he basically said the same thing in fascinating terms about chip design and about the architecture of compute. And I have no doubt in my mind that Larry is going to start right in by saying something about Carver. So Larry, I'm going to go over to you.
Well, Mark, it's fabulous to be back with you, the whole FIRE family. I've missed it. So I'm really pleased to be back here. You know, I guess it's been almost 20 years that I've been involved with FIRE. Mm-hmm. And I got to say, Mark, your conversation with Carver Mead yesterday, I think is the most profound conversation I have heard at 20 years of FIRE.
Wow.
It was like in Foundation having Harry Seldon appear and explain that this is what's going to happen in the future. And his architectural outline of how biological systems, evolved systems over hundreds of millions of years are distributed is the key architectural statement of why you and I are having this conversation, which is to say, well, if that's true, let's find a few examples in the world and let's dig into them a little bit. But I was, you know, Carver has always, he's like 15 years older than me, but he's always been one of my heroes. And he's not the standard down the middle Silicon Valley person. He is, in my mind, one of the most important people in the history of computer architecture. And I think everybody who had a chance to hear him yesterday, and you're fabulous in your ability to bring out his ideas. It's a great conversation. They should just feel honored that they were at that conversation.
Well, and I'll mention, and most people know this, that we recorded that. And so all the people who are registered in our audience will be able to see that on for a year going forward. So we'll find, I hope, many others to share that with. It was really exciting. I had more fun than spit, as they say. And, you know, I'm still kind of wondering what happened there, but it was magic. It was really something.
Well, you were able, Mark, you were able to pull out of Carver these statements of not only how distributed systems are the way that biological intelligence works, but that we're at this, as he said, a great time. He kept saying that over and over again. This is somebody who's worked for 50 or 60 years straight on the frontiers. And he said, oh, but that was just warm up. Mm-hmm. What we're going through now is a fundamental transition from central to distributed. And you know, it's not like we haven't seen this movie before. You know, when we were young people, Mark, and the mainframe behind the glass walls with all the dumb terminals associated with it. I can remember doing computer graphics on those dumb terminals on light green, on dark green, Tektronix graphics. And then in the decades since then, as those smart terminals at the end became powerful computers in their own right, as Carver was saying, like the retina to the brain. Of course, now you have unbelievable computer graphics in computer gaming and everything else, and you have this global, totally distributed system that we just sort of take for granted, that's tied together by the internet.
So I'll just throw in here, since you threw me a softball, that we'll have your friend Chris Johnson on right after, well, soon after this, and who is probably the world expert on visualization, et cetera, using AI as a hinge point. So that'll be fun too.
Now, Chris is one of the great pioneers of computer visualization and a longtime friend and colleague.
And you'll recall we used the retina as a kind of talking point. We had the world expert on the structure of the retina as a pre-processing part of the brain at FIRE a few years ago. So all this stuff kind of fit together really well.
Nope.
Larry, I was saying this morning to one of our tribe, our team, when it was about this interview with Carver, and I think it'll be about the interview with you too, that the point, when I'm doing interviews at least, the point is not the usual thing, I guess, but that to fully engage with that person, first of all, and then come to some new understanding together that neither one of us expected, and then to have some creative act by the end where we all learn something new, and that's it. That's the whole deal. So we have to do that together, you and me, Larry.
Well, let's go.
Okay. Now, so I want to start with a serious complaint about the world, not about you. And, I watched all these guys building the cloud, competing with each other, Google and Amazon and Azure. And I watched what they were doing, and yet they didn't do it. And what they were doing was competing, a lot of money at stake, very competitive. And then they realized AI was going to be the differentiator. And so suddenly they were positioning against each other with AI. Then they saw it was like AI and healthcare. Okay, keep going, guys. But when you really took a look, it was pretty sad.
Mm-hmm.
And it wasn't what they had to do to be great. It was just a marketing ploy, in my opinion. So I want to go to that point and say, we'll come back to the cloud in a minute, but I want to say this conversation that you and I are going to have now about distributed AI in this kind of system you're already describing, that Carver also described, mm-hmm. That's a big deal.
I think it is. I mean, we're very familiar with the use of machine learning in the cloud to monitor everything we look at and post advertisements to our feeds and all the things that are actually the fundamental business model that makes the cloud possible. But that's not where places like Tesla and Google Assistant and so forth are going. And so yes, it's a distributed system, but it isn't the sort of thing that Carver was talking about.
No. As a matter of fact, this whole here we go with disruption, I think, because while the big kids are selling more gym shoes to teenagers using that technology, here comes Tesla.
Yeah. And what we've done in our own National Science Foundation research funded grants is we have spent the last 20 years, since FIRE basically started at the Del Coronado, building national and international scale distributed systems tied together with optical fibers that are capable of nowadays 100,000 megabits a second. So call it 1,000 times the normal internet, which essentially means that these call it a distributed set of PCs or super PCs, but they're all commodity. They're all based on commodity. Act as if they're in the same rack. This is what's so amazing. I mean, the cloud has data centers that are tied together by fiber optics. And those data centers are full of PCs in racks and racks. And so in a way, what we did was blow up a cloud data center and spread it around the world, or blow up a supercomputer, which these days is all just a couple PCs, GPUs, 64-bit GPUs, and CPU core, multi-cores. But the amazing thing is that with fiber optics and just using TCP/IP internet, you get this thing, which is like Carver was talking about, the distributed brain, where the eyes, the retinas on the stalks of the optical network are the brain. It's just extruded out like that, or the nerves that are down all the way to your feet, your solar plexus, your second brain, and your gut are all just this distributed set where important calculations are being done and important sensing all throughout that distributed system, not just in the brain. I love when Carver is talking about, well, yeah, you can grab all this data and make big files, and then the files sit there, and then you can look at the files. That's what's doing now. But where you're doing this, to make it, he kept talking about making it real time and event driven. And that's what the big change is. So
and pre-processing massive amounts of data before it gets to the center.
Right. And by pre-processing, actually selecting much more higher value objects to send back for central processing.
Right. So in the Pacific Research Platform, which is the PRP that you're talking about, NSF funding.
NSF grant, yep.
Right.
I'm principal investigator of.
And we've talked about that at FIRE a number of times. So people who've been FIRE people have already heard this story at a base level. But now I think you're coming back saying running AI at the edge.
Right. So let me give you an example. If you remember in FIRE, the CTO challenge in 2008 was about wildfires. And we actually had the head of the San Diego County, one of the commissioners, we had some of the fire chiefs and everything. And the whole thing was very excellent CTO challenge at FIRE that came up with a lot of good ideas that were later implemented. Well, what's happened in the 13 years since then? And as you remember, one of the things that we had back then in 2008 was we had deployed several hundred cameras on the mountaintops around San Diego County to every minute, say, take a picture of what was down below. And we stored all of those. So if you think about, let's see, every minute times 24 hours in a day times 60 minutes in an hour times 13 years, we have millions and millions and millions of pictures. Not very helpful. Big files, like Carver said.
Yeah, right.
So what we realized is, though, as the technologies develop, Silicon Valley, particularly with things like the IoT and so forth, is we have been talking about this coming for years, low energy machine learning accelerators at the edge. Well, we have now got those things actually on the individual cameras. And so what we've done is gone back into the millions of images and with help from the humans, figured out where are there smoke plumes appearing. And we can begin to train up in the like on the supercomputer a neural net that recognizes in an image that that's a smoke plume. Now, it's not the marine layer coming in, it's not fog, it's not, so there's a lot of differentiation that the human has to say, basically to label the data that's plumes. But once you get the AI, the neural net trained up, and then you can deploy that with the weights it's got on the low energy accelerator at the camera. Now what happens is the camera sits there and it waits and waits and waits and waits, and then all of a sudden it sees a smoke plume.
Event. Yeah.
It's event driven. And so, but what does it do at that point? It doesn't just send it to the files. It can then send a command to the supercomputer to start executing a wildfire simulation where it is estimated where that smoke plume is coming from. But since we don't know exactly where it's coming from, but we do know in real time where all the wind is and the humidity, and we know all the fuel load and everything else, it does an ensemble calculation. And then it probabilistically figures out where the most likely development is. Now, this is all before anybody notices there's a fire. So this is the advantage of taking this event-driven approach, is that it can then be a signal to set off, not at the edge, but at the center, a much more powerful and faster than real-time simulation of what must be coming next. That is all hooked into the emergency command center, and it allows for pre-positioning of equipment, everything else. That was a dream in 2008. I mean, we talked about that's the way it ought to be. Now we're doing it. Now we're actually deploying these devices on the cameras on the mountaintops all over San Diego.
Mm-hmm. Do we get to have satellites at some point?
Do we what?
Get to have satellites involved here at some point?
Well, yeah. The trouble is the satellites at best are going to give you one pass. I mean, it depends on how you're doing it.
So would drones be better?
Well, we're using drones, and we certainly are using AI accelerators, machine learning accelerators on the drones. So the drones can actually be sending back this thing. There's a lot of detailed controversy about the use of drones around wildfires, because you don't want to interfere with the airspace for the tankers coming in to drop fuel and drop suppressant and so forth. What we're trying to do, we're actually working with a power company, SDG&E, and they, of course, are using drones along the lines to avoid starting the fires. So
maybe the deal will be to put the cameras on the firefighting planes.
Well, we actually, one of the experiments that Hans Werner Braun, who was the developer of the high performance wireless research and education network and one of the early pioneers of the internet, he actually was able to take and put one of these wireless antennas on the planes that the pilots take off from our local fields, and then they are scanning where the edge of the wildfire is. They used to have to take a picture, come down and land, put it on the fax machine and send the fax. That's where we were in 2008. And so now they're hooked into this wireless, and this wireless network, by the way, is a good fraction of a gigabit per second these days. Okay. Point to point.
Yeah.
And so it's all now become this kind of integrated. So think again, Carver's idea of this distributed brain. So now the people up in the plane, the eyes in the plane, are not only sending back real-time information, but they are able to receive everything about where they ought to be going to, what's the maximum use, optimal use of their time in the air and that sort of thing. So it's, again, this totally interconnected system.
So I'm just going to underline the difference between yesterday and tomorrow, because I think, whatever, I'm not saying anything against Amazon or Google or Microsoft or whatever else, IBM, but the idea of Azure or AWS as currently being operated, with some things where you can click in AI stuff as you wish if you're a developer, or you can use it for selling things if you're an advertiser, that's fine. But this is very different.
Well, and let's take it a little bit further now. I mean, we have hundreds of cameras, but let's talk about Tesla. As a proud owner of a 2022 Model X, a
long-time Tesla owner,
and 5 years before that with the first version. Yeah. There's been a huge transition in that 5 years. When I bought my first Tesla, 5 years ago. It had one camera and behind the rear view mirror looking forward, and it had ultrasound sensors. A few years later, Elon bet the farm on computer vision, and he put 8 cameras and an NVIDIA GPU in the car to actually use computer vision to figure out where what the environment is the car is moving through, and to control what became known as full self-driving. Well, now I've just gotten one of those cars that has the 8 cameras. I'm one of somewhere between 1 and 2 million of the Tesla cars that have cameras. So let's just call it 8 to 16 million, call it 10 million cameras. And each of those cars has what is way more powerful than the Cray 2 supercomputer I first bought at NCSA back in '85 on board, but optimized to do machine learning and computer vision on video, and from 8 different cameras. So think of Carver talking about the brain with the optical fiber and the 2 eyes and the retinas. Now what Tesla has is let's call it a 10 million eye brain. And those retinas, those either commercial like NVIDIA or more recently Tesla has its own internal chip development team, and they are making their own full self-driving processor optimized for exactly the task. Just like Carver said, you have to build a specialized processor to do the specific actions you need to provide the machine learning on the quantities that your sensors are bringing in this case, computer video, and then to fuse it to create a 3-dimensional. Remember, he kept saying, we're talking about space-time patterns.
Mm-hmm.
That's what the car is moving through. The environment and its movement is a space-time.
And he separated space and time, which I thought was very, very interesting.
Right.
And one of the stunning quotes from him, which you will remember yesterday, was that, and I'm going to try to say this carefully, that the amplitude of the wave is digital in space and analog over time. And I just thought, oh man,
right.
This guy's so far ahead of us.
Well,
Yeah.
And I'm not here to say whether or not Tesla is going to succeed at whatever full self-driving means to you, since that's a pretty ambiguous term.
Yeah.
But it is to me, one of the most amazing engineering achievements in history.
Yeah.
To have 10 million cameras in real time coming in. And what happens, of course, is then they're building the Dojo supercomputer out of customized chips they call the D1. They're building up a whole series of these that, if it can be done, and there's some interesting technical controversy about whether he can deliver, as there always is with Elon, what he says he's going to do. Certainly there's a question of whether he can ever do it on the time scale, since he never does, but he does deliver in the end.
Yes,
and so this is a super bandwidth set of chips. The speed between the interconnections of these things are just unheard of. This is very far from commodity. But what it is it's designed to specifically do machine learning on, let's call it 10-second video clips that come from the cars. Why does they come from the cars? They're not going to send, there's not enough bandwidth in the world to send the video from 10 million cameras into headquarters all the time. That's crazy. And so part of the reason that Carver talks about the necessity of having this distributed
Yeah.
computing system, the
Yeah.
distributed brain, is you can't afford not
You
you
have to.
can't afford to send all the raw data. That doesn't make any sense. So,
Same with the brain. You couldn't
so
send
what it is
all the bits from your eye to your brain. It wouldn't work.
so that's why the retina does that pre-processing instead of just like you say, this vast incoming stream of photons. And so as I understand it, and again, I don't work for Tesla, I don't have any I don't have any inside information. All I'm talking about is stuff that's available in the public media. But fundamentally, what the head of their autopilot division says is that they are trained up neural nets on their centralized computer, which currently has been made of NVIDIA chips. And then if this year is supposed to be the year that the dojo is actually made functional, we'll see. And so what they're looking for is they then take that neural net, just like we did with the smoke plume after we had gone through the millions of pictures, put it back into all of the 1 million or 2 million Teslas. That then is executing against what the human in the car does.
Yes.
And when I'm going down the highway, there's an on-ramp coming in. I see the car coming up in my side vision, and I am not sure that the Tesla sees it and understands it's got to slow down to let that guy in instead of cratering me on the right side. And so I will tip the brake and take it out of auto drive. Okay, so
Loyal employee of Tesla.
So what it does is it takes that 10-second video, takes that and sends it up to headquarters. And so whenever what it thinks, what its AI says should have happened, what the car should have done, is different than what the human in the car does.
Yeah.
That's an exception.
Yep.
That is what goes up.
That's an event.
That's an event.
Yep.
And then they have a lot. This is not just black box magic. They have literally hundreds of people that work on going in and understanding these edge cases, these exceptions,
Outliers.
and then they go in and tweak the underlying neural net, which then comes out in a new release. So what I find so amazing about this is that
we all work for
my
Elon.
role as a human is to train.
It's Elon's world.
The AI to take over my role as a human,
as a driver.
Car.
Right.
And I guess I should be honored that I am one of the last generation of humans who will be needed.
Elon.
And what is even more amazing, Mark, I spent $10,000 as part of buying the thing to get the full self-driving module, right?
Absolutely.
That doesn't mean I get to use it.
Nope. Oh, really?
Because I am being graded. I have to, I look up my Tesla app, okay, and I go down to where it says safety score, and it has been following me. I got a 95, which you'd think is pretty good. No, I am not a good enough driver to be allowed to put the final touches in this next year on full self-driving. I am not good enough. So only the top, it started as 100, you had to have a safety score of 100. Now we brought it down to 99 or 98. So maybe the top 2% of the people who are driving Teslas are good enough drivers to be allowed to be tutors to the AI for its finishing stages.
Makes sense, because those finishing stages are the most expensive computationally.
I mean, this is, and I gotta say, I love Tesla. I love you all. Driving one of these cars it's not like anything. I've spent 50 years driving cars. It's not like anything else I've ever done. I'm not driving. I'm sitting there watching it drive and trying to understand how it's thinking and how it makes decisions. Since it's my life and my family's life in a car that's at risk at 75 miles an hour. Um, and yet I see it's a process that by 2025, it'll be complete. I will not be needed.
I want to purely out of a selfish interest, self-interest. I want to mention that you met Elon during one of his, probably the first time he showed up, one of his 5 times at Fire, and you probably drove your first or got driven by him your first time in a Tesla by Elon, and went to SpaceX.
I think it was 2006, maybe, Mark. I had lunch at Fire with Elon just because, I mean, in the whole history of Fire, the fact that you brought Elon to us is one of the most important things you ever did. And not just for us, but for the world. I mean, you know, when you brought Elon in terms of SpaceX, the Falcon 1s were blowing up.
Yeah, they were. I remember.
And Elon is just a few in a century human. I mean, here's a guy who's saying, well, the business plan of SpaceX is we're going to be building a 1 million person, human city on Mars, all made possible by the Starship, which, and by the way, we'll probably be there in 4 years. And the only thing is the Starship hasn't actually gone into orbit yet once. And we don't know, it probably will explode on the pad, but we you know, we'll be having, by this decade, we'll have 1 million people on Mars. This is not normal human.
He's a great guy. He's a great guy. He's one of my heroes too. One of the top 3, I would say. So Larry, and then later we'll talk about Jensen on stage, which I mentioned the other day. That was a moment, I mean, in computing history, I think, because he still saw himself as making GPUs for video games. And we had been writing for 2 or 3 years about XY computing, where you take that GPU, you put it on its side, and you turn it into a CPU. And boy, that worked, you know. So Fire is a pretty cool place. So take this for us from Tesla, where we are now, to the next level. I mean, you made a really interesting statement the other day that this isn't about cars. So let's go there.
Yeah. So, you know, there are on the screen here, you have people that are quite a bit deeper in than I am on understanding general artificial intelligence. And certainly Elon is making comments that, and his head of Autopilot, that this is meant to be a general vision system. And during the last conference call for Tesla, he made a lot of financial analysts unhappy, because he said, actually, this year, the #1 project for us is the Tesla bot, otherwise known as Optimus, from Optimus Prime. And the reason is that it will use the artificial intelligence system developed for the cars to drive the robots. Right. And the robots will be used for dangerous or, you know, heavy activities that it would be better to have a robot than a human doing. But it plans to use exactly the system that is being perfected using cars. So the cars, it's Carver all over again. Once you have this distributed brain that is interacting with the world, and I want to really emphasize that is the key issue. The reason a baby, you were talking to him about the baby being born and then the baby brain developing and everything. We've known for many years that the way that the brain develops is through interaction with reality. And it's that constant event-driven set of things that the brain reacts to that leads to its development.
Yes.
And so if you don't have, it's not enough to have, if you don't have a distributed system, forget it. Now you got a distributed system. Is it interacting with the world on a moment-to-moment basis? Because that is where the learning happens.
Yes. I'll add that there, and I know you know this, there are people in academia somewhere, you know their names, I'm sure, who have posited that, I don't want to use the word consciousness, but let's call it awareness, that there are kind of creative acts that may be emergent from compute systems in the kind of evolution forward that you're talking about.
Yeah, yeah. And, you know, like I say, I think Elon is, as usual, overestimating how quickly
Sure.
this will all converge to where he can have his fleets of auto taxis and so forth. I think it's going to take longer, as everything he says takes longer. But on the other hand, I think he is an incredible engineer. And if you look at the fact that they just landed the 100th booster for Falcon 9, and if you remember, the first 3 or 4 were blowing up and they were hitting the ship and so forth.
Yeah.
Okay, but he got the whole fundamental reason that happened, that was such a success against everybody laughing at him, is engineering iteration. It's all in the software. The sensor flows into the software, the machine learning in the software, and then every time you do it, the software and the integrated system of sensors gets more and more accurate until you never fail.
I don't think anybody ever put as many sensors on a rocket as he did. The telemetry coming off those rockets, even when they failed, of course, was amazing.
Yeah, but it's the fact that it's a learning system.
Yeah.
And that's why Elon makes statements like, I think self-driving is a pretty simple problem and it's more or less completed. I mean, that's Elon talk, but look what he did with the Falcon 9 booster. And of course, the ability to land and reuse some of these now boosters have been used many, many times.
Right.
That is a secret to the business model to get the cost of getting into orbit down to orders of magnitude below what it ever was before. So I'm the thing I love about both the PRP and this is I'm a participant. But I want to take you one step further, Mark. Yeah. What we're talking about is millions of cameras, but I want to go to billions. And so, you know, like
I want to throw Starlink in while you're doing that.
Well, before you get to Starlink, which is another very interesting idea, if you look at Google's assistant, digital assistant, that is now deployed on something like over 1 billion devices.
Yes.
And, you know, in my own home, of course, Joseph, my son, worked for Google for like a decade, and was very much involved in the digital assistant program. And again, I don't have any inside information on it, but, you know, if you look at the Nest cams, I bought Nest and then I have 6 or 8 Nest cams in my house, and I have digital assistants on everything. It's very interesting to live among the AIs because they each have a voice and it seems like a personality. And that's what is really interesting is that they cooperate with each other, which of course was built into it. But I think a lot of people, if they don't have enough of these AIs in their house, don't appreciate that they form a community that is an interactive community with the humans. And it's so strange to, I mean, I kind of love living with the strangeness, but you know, you'll say, hey, Google, and at just that moment, of
Watch out.
course, two or three of them are waking up right now.
Yeah, careful.
And so how does that work? Well, it's not that they're sending back the conversation we're having to the Google Cloud. They couldn't be spinning out all this stuff. So what they have is of course, the processors that are either on, my Pixel phone or in the devices themselves. And those are Carver's, distributed processors that are doing event-driven things. So when you say, hey, go, that's an event, that sets off something. But now the Nest cams, for instance, can do facial recognition.
Yeah.
And they're not sending all of the video back to the cloud. They are doing that on device. And they are, forming basically neural nets of these faces. And then they will ask the human, is this your son? Is this, who is this? Who is this?
Larry, are you sure of that? Are you sure of that last sentence?
Yeah.
Are you sure they're doing the facial on the device?
Yes.
They are. Okay.
On the new generation of Nest cams, not the old ones.
All right.
Hey everyone, I just want to say we're about to take audience questions in about 5 minutes. So if you have questions for Larry or for Mark, drop them in the chat now and we'll call you up.
Thank you, Brett.
And so that brings up a really important, another advantage of Carver's architecture, which is privacy protection.
Mm-hmm.
So a lot of people worry, and if you don't have this distributed capability, you have a lot of problems with privacy. But this way, the storage of the face representations is on the local device. And so I think that also is, a lot of the countries in
Let me
Europe,
add, not in China.
well, you're right. A lot of the countries also are saying now to the cloud providers, any data that's generated in our country has to stay in our country. Well, that's okay if you have federated learning, where you send out like an AI, a neural net to the data, form these, not the data, but these modified weights on the neural nets, and then send the differences, the gradients back. You're not sending any data. And we use this, for instance, in distributed healthcare. Like if you have radiological databases that are secure, and it's in UCSD healthcare, and other ones at Irvine healthcare or whatever, well, you'd like to pool all those to do radiological machine learning, but you can't pool them because you destroy the privacy. But you don't need to. If you've formed a neural net on a set of the data, then you send that net, you rerun it against the data locally inside the stockade, adjust the weights a little bit, send the adjustments back. You don't send anything back about the actual data itself, which preserves privacy. And also allows for the EU to continue having its regulations that the data has to stay local, and yet that doesn't have to stop machine learning from progressing.
Right. Now I'm going to anticipate Barrett coming right back in a second. And first of all, thank you, Larry, as always, high point of my day or week or a month. And then also mention everyone, tomorrow is Advanced AI Day. So if you like this stuff, hang around, because all day long tomorrow we'll be talking to experts in machine learning, AI, and advanced mathematics. And at the end of tomorrow, we will have the special Investors Day with Pattern. We're going to do a big reveal on the first explainable AI in the world. So a lot going on tomorrow. And I think Barrett's waiting in the background for me to turn this over to her. So with no further ado, Barrett, over to you.
Yeah, so the first question is from Rennie Gleason. He is wondering if Elon's interconnected drive systems won't let us drive because of human inefficiencies, what else might it preclude us from doing or even knowing about?
Larry?
Well, I'm opting in. I mean, Tesla isn't telling me to do anything I didn't set out to do when I bought a Tesla. So I think there are perhaps questions about more general systems. But in this particular case, I think when you buy a Tesla, you're opting into, being a part of this learning process. And that's one company that happens to be doing this. The general use of this distributed system by others could be problematic in some of the ways you're implying.
All right, the next question is from Marshall Kirkpatrick. So his question is, how do you think about the models humans in the loop versus computers in the loop per MIT Center for Collective Intelligence?
Yeah, well, for now, and I think for quite a while to come, humans are still the supreme level of intelligence on this particular planet. And so having them in the loop is essential for bringing up the next generation of software intelligence. And you're training up these AIs for usually fairly specific, even self-driving is a pretty specific application. And so there was some discussion yesterday about, will this ever lead to a transition from application-specific intelligence and software to general intelligence, meaning that it can reason and in face of uncertainty the way that humans can? I have no idea. I mean, you could have Ray Kurzweil in and have him speculate about the singularity and whether it's going to happen or not. I don't think we can know, actually. So stay tuned.
Yeah, now that I can speak unmuted, thank you for that. I think I was thinking more the opposite direction, and contrasting. I really like the catchphrase of moving from the human in the loop model of AI to instead computers in the group of Wikipedia style human-centric models where the human agents outnumber the artificial agents that are acting in service of them. And while all this distributed computing is incredibly exciting, the interoperability of distributed social networks, similar to what I know your son to have worked on years ago, for example, it was so inspiring, seems like potentially models in conflict. And I wonder if there's...
Yeah, I mean, it's pretty interesting if you look at what social networks have come to when you essentially democratize everybody's voice being equally important, regardless of whether they have any, I would say, education about the topic they're talking about, if it's facts-based or not. A lot of course, our society is not built on fact-based, but faith-based thinking, and that translates directly into social networks. I mean, social networks, I think, are really valuable for revealing what humans are really like.
Yep.
Which isn't a very pretty picture.
Nope.
But I think we've fooled ourselves by thinking that a lot of what you see now happening is not there, but it is. And essentially, when all of the constraints are taken away from humans just saying it the way they think it is, what you see is actually it's probably very important in the long run for us to actually have our blinders off and see what it is we're dealing with humans.
It would be great if the technology and the humans could work together in service of the humans.
Marshall, I'm glad you said that, because what I wanted to end up with is talking that about exactly that model, that what we're seeing is what NASA called, in terms of future space exploration, humans and robots and computers exploring together. So it's a collaborative activity. And the AIs ought to be viewed as working with humans. Now, I will say that a lot of humans are using AIs as, for instance, bots and social networks in a way that while it is collaborative for them, it is very disruptive for the rest of us. But I think this idea of it's not like Terminator. It's not like the robots are often running on their own. It's really still a pretty collaborative human AI activity, whatever it is.
All right, we got one question from Oliver Dominic. Oliver, are you around? Do you want to unmute? He says, I wonder what emergent properties may appear as distributed processing, AI, etc., continue to evolve and to accelerate their own evolution through machine learning. It's my impression that emergent properties are generally not predicted or anticipated. Thoughts?
I think it's a very good use of the term emergent properties, and I have been writing about this for several decades. And because it's emergent, it's not predictable. I mean, that's the whole point of emergence. And I think I will say often that, we may be the last generation of humans that actually control these things. I don't know that's true. David Brin, if he were here, would be a much better person as somebody who looks many more centuries into the future than I do, in terms of what's possible. But the exponential change that is built into computing on a sustained basis will take us places that we've never imagined. And that's why Ray Kurzweil wrote The Singularity. That's what the whole series of books he wrote were about, is projecting that exponential growth out, 10, 20, 30, 50, 100 years into the future. And then pointing out, if that exponential doesn't continue, we will end up with sentient capabilities in software and computing that is far beyond what we have now as collective humans. And I think he could be right. There's no way to know.
Larry, I've never been a big fan. I like Ray a lot, but I've never been a big fan of the singularity idea. And I'd like to suggest that we had the singularity back when the IBM 360 was born, or never will have it. But the whole idea, I think, is fraught. It's just a good fear play. On the other hand, I think that I know we're working now, and I think you know this, on tying the mathematics of complexity and chaos theories into flow and interaction fundamentals, and actually trying to get real mathematics involved in pattern recognition, so that we can in fact predict emergent qualities as they start to happen. And we're not there yet, but I can see that framework working. That may be one way to answer Oliver's question.
All right, we are out of time. I want to make sure we give everyone enough time to move to the next session. Larry, thank you so much for your time and expertise. I think you've blown everyone's mind once more.
It's wonderful to see you, I should say.
You too. I only wish you had a few more orchids behind you. Is my only.
Well, there are about 70 blooming orchids in the house. So
for those of you who don't know Larry, he is an immaculate orchid gardener and has an incredible collection. So
thank you, Larry.
That was my pleasure.
That was great.
Thanks, Larry.
See ya.